This presentation is an update of the innovations in the processing industry that can help tackling the meat quality issues associated with entire male pigs and immunocastrates. Introduction of new alternatives to surgical castration is becoming a reality in the European pig rearing sector. Entire males and immunocastrates are metabolically very different from the conventionally used surgical castrates. Surgical castrates experience early castration. Compared to them, entire males have a lower feed intake and higher protein deposition abilities. Late castration is practiced in immunocastrates, which behave and perform like entire males, until the second vaccination. After that, they experience rapid metabolic changes, resulting in increased feed intake, fast growth, and acceleration of fat deposition. Those differences are reflected in carcass composition and meat quality. In addition to the presence of boar taint in entire males, changed or reduced meat and fat qualities in entire males and, to a lesser extent, in immunocastrates, also affects the meat processing aptitude and final product quality. The aims of this presentation are: 1. To investigate indicators of potentially reduced meat quality traits in entire males and immunocastrates. 2. Evaluate the impact of the use of the two alternatives on meat product quality, and update knowledge on solutions to alleviate these problems. 3. Update the available knowledge on the possibilities to valorize products prepared from meat with boar taint. A paper providing a systematic overview with recommendations on the use of meat from entire males and immunocastrates for meat products will be published in a special issue of the journal Animals. In general, fat quantity and saturation decrease from surgical castrates to immunocastrates to entire males. Compared to surgical castrates, entire male fat contains higher proportions of unsaturated fat, water, and collagen. It is softer and has inferior tissue cohesion. Fat properties in immunocastrates depends on the delay from second vaccination to slaughter. 6 to 8 weeks after vaccination, fat composition becomes similar to surgical castrates. Possible solutions to this issue include dietary modifications, like feed with low polyunsaturated fatty acid content, in entire males. Immunocastration, especially with extended delay, from second vaccination to slaughter. Male category notably influences meat quality traits. Studies report inconsistent results in regard to muscle pH, whereas indications for darker meat color in entire males, and lighter color in immunocastrates exist. In both cases, the differences in pH or color are of little practical importance. More serious are the issues of inferior water holding capacity in entire males, and possibly also immunocastrates, and of increased meat toughness in entire males. The causes for these defects include higher aggression, activity, and stress prior to slaughter, decreased adiposity, causing differences in carcass cooling rate, higher collagen, and lower intramuscular fat content, while the most likely reason seems to be high fat unsaturation, causing protein oxidation. Possible solutions include changes in rearing and management practice, or adaptations of meat handling procedures. Immunocastrating entire males increases fat quantity and saturation, and results in similar eating quality than in surgical castrates. Lowering pre-slaughter stress and aggression, by preventing mixing of animals in entire males, may prevent pH-related defects. Procedures like optimized cutting, by preventing muscle structure damage, cooking at lower temperatures for shorter time, selection of appropriate meat cuts, like shoulder instead of ham, and prolonged aging of entire male meat, may all minimize risks associated with low water holding capacity and toughness. The aforementioned meat and fat quality issues may notably influence the properties of various meat products. Entire males are not suitable for dry-cured ham production. Indeed, producing dry-cured hams from entire males is associated with more skin lesions, and issues related to high leanness. It results in low processing yields, higher salt intake, tissue separation, hard texture, and inferior aroma, other than boar taint. If one wants to use them anyway, Weight losses should be closely monitored and adapted to lower excessive drying and salt uptake. Immunocastrates are a better option, although conventional vaccination protocols, with 4 to 5 weeks of delay from second vaccination to slaughter, still make them very similar to entire males. Extending this delay to 7 to 9 weeks improves the quality of dry-cured hams. Similar problems can be observed in raw fermented sausages, and may be counterbalanced by replacement of entire male fat, with the fat of castrates or gilts, by lowering salt addition, and by microbial inoculation, lowering water loss, increasing proteolysis and lipolysis, and improving volatile profile. The use of entire males for production of cured bellies or bacon results in more skin lesions, saltier product, lower curing yield, and higher slicing losses associated to lower brine retention and lower fat content. The products are more acceptable to consumers due to high leanness. Adaptation of curing, processing, and slicing parameters like temperature or duration is needed. In immunocastrates, increasing the time interval between second vaccination and slaughter from 5 to 7 weeks eliminates the differences from surgical castrates in external appearance, slicing losses, and tissue cohesion. Not much research exists on other meat products, like restructured meat or emulsion-type sausages, made from entire males. The existing literature reports either no difference with surgical castrates, or some indications of increased oxidation after prolonged storage, or problems with water binding after emulsification. Close monitoring of product during processing, and controlled use of water binders and antioxidants, is therefore advised. When using entire males, another serious issue is the occurrence of boar taint in meat, and meat products. Thermal treatment potentially reduces the levels of boar taint compounds, by either evaporation, chemical degradation, or partial washing out of scattle by purge loss. In regard to lowering boar taint perception, open cooking is better than closed, whereas frying in oil is better than roasting, baking, grilling, and cooking in vacuum package. Roasting is better than cooking in water. High-temperature procedures are more efficient. Masking by marinades, containing liquid smoke, or spices with distinctive flavors, is successful at low to medium boar taint levels. Embedding in breadcrumbs, and serving in a complex meal, like in a sandwich, or with cheese, can also help. Acceptability of highly tainted material can only be assured by smoking and dilution, which is dependent on the product type. There are indications that dry-cured ham processing decreases scattle and androstenone levels to some extent. Still, the process of dry curing alone was not confirmed as sufficient to prevent boar taint, despite lengthy maturation and generation of flavor compounds. Most of the dry-cured hams are not smoked, with low amounts of added spices, so masking may not be sufficient. The problem of boar taint was more pronounced in hams with low salt content, due to the interaction with proteolysis. Production of dry-cured hams from tainted material is not recommended, especially in combination with salt reduction. Cold consumption, usual for this type of product, and removing subcutaneous fat layer may be, however, beneficial. The process of dry fermentation alone, in combination with conventional spices, does not effectively mask boar taint, especially at higher levels with androstenone concentrations higher than 1.0 ppm. Some better degree of masking may be achieved through fast acidification by microbial cultures, or chemical acidifiers. Androstenone levels do not change much during the process, while some minor reduction of scattle was detected. Lower risk of boar taint perception can be assured by cold consumption, while higher boar taint levels can be effectively masked by long and intensive smoking, or, with even more tainted material combining smoking with dilution of more than 50%. To a certain level, boar taint can be reduced or masked in various kinds of other meat products, like cooked ham, bacon, or emulsion-type sausages, depending on boar taint concentration, fat content, processing, and consumption mode or masking method. Cold consumption of products like cooked smoked ham, or emulsion-type sausages, greatly decreases boar taint perception. Processing like brine injection and cooking may dilute, or decrease, boar taint. Further effect can be reached at low to medium boar taint by masking with flavor enhancers, high amounts of spices with distinctive flavors, and polyphosphates. Smoke is the most efficient masking agent. In highly tainted products, raw material should be further diluted by 50 to 70%. It can be concluded that introducing entire male or immunocastrate production may affect the quality and processing, due to the changes in fat and meat quality. Knowing the quality of the fat and meat of the product is important to ensure a good carcass and meat quality classification, and to optimize its processing. To avoid a decrease in quality, various management and processing strategies need to be considered at farm, abattoir, and processing plants. Boar taint is another important quality parameter present in entire male pork. Boar taint reduction and masking strategies, such as use of microbial starter cultures, thermal processing, use of spices, smoking, and dilution with untainted raw material, have been proven to be a viable solution to valorize this type of meat. Thank you for your attention.